I'm just going to eyeball this. Okay. So this is approximately where your 29 is, right? Then from here, you know that the shear is so small, 1.608. Okay, so the shear is very small. So I know we wrote negative shear over here, but it all depends on the rotation of the element, which I will explain later on what do I mean by that. Okay, so come on. So this is your shear. Okay, I'm going to copy. And then this is your shear. Okay, so this will over here will be your stress Z line. Okay. So if we look at stress X, okay, we look at X, right? It's on the 0-axis line, and it's going to rotate the element. Okay, so this arrow is going to rotate the element. So if you put your finger down here, right, the yellow highlight arrow will rotate the element in a clockwise direction. Okay, so this is your point X. Okay, and then for your point Z, okay, the blue arrow, hey, Eugene, come on. The blue arrow that I'm going to highlight is going to rotate the element. If you put your finger in the center, rotate in a anti-clockwise direction. So over here, this is your point Z. Okay, there is your point Z. So from here, you can draw a line, right? Right. So you can also calculate your stress average. Mathematically, it's so easy. Okay, so you can calculate your stress average. So your average stress or center of the circle. Hey. Oh, sorry, I do apologize. I think I'm just going to write down here. So center of circle is also known as our stress average. So our stress average is equal to stress X plus by stress Z divided by 2. So this is 0 plus by our stress Z is 29.852. So this will be equal to 29.852, and then the whole thing divided by 2. So our stress average is at 14.926 megapascal. Okay, so I'm going to draw a line for our stress average. I'm just eyeballing this. Okay, so 14.9, so it's quite close to here, right? So the distance from here to here, this is known as your stress average. Okay, and then from here we can also work out the radius of the circle. So radius of the circle will be known as your tau max, right? So tau max will be equal to for this case your stress average, which is 14.926 squared plus by the 1.608. So this will be equal to 14.926 squared plus 1.608 squared, square root 15.012 megapascal. Okay, so let me do it again. 14.926 plus 1.608, 14.926 squared plus by 1.608 squared, square root of the whole thing is 14.926 squared plus by 1.608 squared, square root of the whole thing, 15.012. Okay, so 15.012. So now we can calculate our, or we can draw our Mohr circle. Okay, we can, so 15, so that is the radius of the circle. All right, so this is the radius of the circle. All right, then I just need to stretch it out here. Okay, and then stretch it down here. Right. So because the circle touches point X and point Z, this circle over here belongs to the XZ plane. Okay, so I've not done this when I was teaching 3C on Mohr circle, but this one I go to more detail. Okay, so that's your circle on your XZ plane. So there are 2 points over here. Right, there are 2 points over here are your principal stress. I think I'm going to use a different color. Okay, there are 2 points over. Okay, so one over here, this is our stress 1, and over here that is our stress 2. Okay, that is our stress 2. So come knowing where stress 1, stress 2 is. Okay, so stress 1 and 2 are the principal stresses. Right, so all you need to do to calculate stress 1 and 2 is a stress average, which is 14.926 plus or minus 15.012. So you have 2 values. Now note, at the principal stresses, the shear stress is equal to what? 0. Okay, so 14.926 plus by 14.926 plus by 15.012, so it's equal to 29.938 times 10 to the power 6 Pascal, and the other value is minus 15.012 is equal to minus 0.086 times 10 to the power 6 Pascal. So you will use these values, okay, you'll use these values, right, to find what material is more suitable. Okay, so you compare with this number down here, right? So this is how you select the right material, okay, by using your what? Principal stress. Why the principal stress? Because in just tension, right, when I were to draw Mohr circle, right, normal stress, shear stress, right, this is the circle there. So if this is your point Y and this is your point X, so over here this will be your point Y, over here this is your point X. This is the value that they got, and that is their principal stress. Okay, and this is what is given down here, because the other value is equal to what? 0. They did not need to put this. Okay, so they quote this number over here, and this is where you compare with your Mohr circle. Okay, so some of you say, Eugene, this is 2D. Yeah, this is 2D. I could not draw 3D for this case is because point X or point Y is exactly down here. Okay, that's where point is. So if I'm going to expand it, right? So this is the big circle over here, right? If these are all your origins, right? So this is your shear line, this is your normal stress line. Over here, this is your point Y is, okay? And this is where your point X, not point X, your stress 2. And we have calculated our stress 2 to be equal to minus 0.086. Okay, so this is minus 0.086, very small. So there's another circle over here, okay, which I'll teach you later on 3D Mohr circle. So this circle over here, is the third, is your second circle, and then you have to construct another circle over here to touch the other side. Okay, so don't worry about this. This is 3D Mohr circle, which I cannot. This is not a very good example because the shearing stress value is just too small. Okay, so this is how you select. Okay, this is how, as an engineer, which you guys all will be, to select material. Okay, to select material for your design. Okay, so it's quite lengthy. Okay, it's very procedure based. Remember what we did last week, right? We have to break everything down. Okay, we have to break everything down to know what is a normal stress. Sorry, we started here. Did we started? Oh no, we start from here, right? We have to break everything down to look at what is the normal stress, what are the shearing stress, what are the moment, how the shearing stress is affecting the structure, okay? And then we have to apply Mohr circle. So this is in fact the primary objective of this course, okay? How to determine what material to select based on the principal stress and based on compound loading, 3D compound loading situation. So this is the real world, basically. That's what I'm trying to tell you. This is the real world, okay? You cannot get more real than that, okay? Now, before I go on any, so what we have to do after this is we have to look into shaft design. We also have to look into beam design, okay? Before we can go into shaft design or beam design, okay, you guys realize how critical is Mohr circle again, okay? So what I'm going to do now for the next, hopefully I can get it done in the next 2 hours or less, okay? I'm going to go through Mohr circle, okay? I'm going to do Mohr circle with you in case you forget, and we will do a few examples, okay? Then we'll help you recap Mohr circle, okay? So let's start with Mohr circle. Okay, I will do 2D, and I will also expand to 3D, okay? 3D Mohr circle is not more complex than 2D, okay? Once you know 2D, 3D is very straightforward. So let's look at normal stresses first. Okay? Okay, let's look at normal stress. So if I were to have elements, okay, so you guys will know what is an element. So if we have our element down here, okay, so this is our element. Okay, and then our element will comply to this transformation over here. So this is point, this is x-axis, y-axis. So normal stress are stresses acting perpendicular to the surface, as you can see. So this is our stress x direction, and over here this is our stress y direction. So they are acting normal to the surface of the element. So for this case, what you see over here when it's pointing outwards means it's in tensile mode. Tensile means it's positive. Also over here you see it's pointing away. Okay, so this is also tensile mode, and this is positive. Right, and I'm going to declare this that stress x, okay, for this case is greater than stress y. Okay, right. So a good habit to do is you will label this x, and you will label this at point y. Okay, so by the side I'm going to draw a Mohr circle. Okay, so over here this is the Mohr circle. So Mohr circle, the x-axis over here. This is our normal stress, okay? And on the vertical, this is our shearing stress, and the shearing stress, I want you to have a good habit to draw that the shearing stress is generate clockwise rotation of the element